Wow. Today we're gonna see what's inside the microwave. Hey there. Not long ago, we posted a video testing some things that shouldn't be put inside the microwave. So, for example, we put a fork, aluminum foil, a lunchbox, and we even lit up an incandescent bulb inside the microwave. In that video, there was a moment when the microwave broke, and I decided to take it apart. But when I was taking it apart, I managed to fix the microwave, and that ended up causing some frustration, right? Because a lot of people wanted to see what was inside. This video here is really for us to finally declare the end of this little guy here. But before we take this thing apart, there's something I want to test. A lot of people suggested that we put a CD inside the microwave because something really crazy happens. So let's do this test while it still works. The phone will record what's inside. And yes, I made a hole here in the back of the microwave. If you saw the other video, you know microwaves don't leak through this hole, so there's no risk of damaging the phone. I'll hang the CD inside with masking tape and see what happens. Ah. Wait. Whoa, no. Not like that. Yeah, I think it's already kind of burned inside from last time, and the rest of the stuff that was there caught fire. Let's see. Cool CD. Fire. The one from the turntable that was on fire. It's already in a bit of a complicated situation, right? Let's do it again, this time without that junk inside. The idea of the CD is that it has aluminum inside. When you turn on the microwave, you induce an electric current in the aluminum, generating electric energy inside it. This energy will concentrate in some spots, and those spots will catch fire. We'll see the CD cracking all over, theoretically. Wow. But it's just I expected more. Try recording it in slow motion, right? Wow. We could remove the microwave bulb to see this happen in the dark, right? But for now, we're just taking out the bulb and won't see inside yet, okay? Bulb is off. The bulb is kind of busted. It was really cool. They left a really tiny little figure here that's on top of a platform saying it's the microwave surfer. But what are microwaves? Could you surf on a microwave? I'm going to check our big science book here. By the way, right below the video on YouTube, you'll see our entire collection of big books. Okay? Science, math, biology, chemistry. These books are really cool. Microwaves are related to visible light. We call this
ondas eletromagnéticas. Então,
the bigger waves, for example, are radio waves, which we use for telecommunication. Microwaves are shorter waves. Visible light is even shorter. They're smaller waves. And X-rays are extremely small. Because of X-rays, I imagine a lot of people are afraid of microwaves. I'm going to get cancer from standing in front of the microwave. My brain is going to melt. First of all, microwaves aren't that strong. Second, there's protection around the microwave oven so the waves don't escape. They can't get through the metal box. And here in the front, we have these little holes, which are small. They're just the right size so the microwaves can't get through. Just so you have an idea, I'm so confident that this works, that we made a little hole in the back of the microwave and put a phone inside, recording. If it didn't work, our phone would be microwave lasagna. People often ask why microwaves have a turntable and why food spins. Since food doesn't spin in a regular oven, it's because these microwaves end up being stronger in some spots. Let's try an experiment to prove this. What I'm going to try to do is take a piece of paper, color it really well with crayon, spread it out evenly, then put it in the microwave and see if it melts in specific spots. In those spots where the waves are more concentrated. Now there's no more light. It didn't make any difference. We're going to have to use high technology here because my old school idea didn't work. I'm going to wet the paper a little And then we'll see on the thermal camera which spot got hotter. It's cool to wet it because microwaves, they agitate the water molecules. That's how the oven works. These electromagnetic waves will make the water molecules move faster and faster at the microscopic level. And that's what heats the food. It's not just water, okay? There are some sugars too. Other molecules also get agitated by microwaves. So, you can put something else that doesn't have water and still heat it up, but it's made for water, okay? You can see inside everything is a little cold because of the water that's evaporating. I'll turn it on here. Even on top of the microwave, it's hot. Ah, look at that. Clearly there's an area that gets much hotter than the other. So you can see that this side here and the middle here got much hotter than the rest. And that means if we had a pie, it would cook here and here, but it wouldn't cook on the other side. And that's why we have to rotate things inside the microwave to heat them evenly. Jansen, who's recording the video right now, is getting really good at asking questions. Sometimes he asks some really tough questions that put me in a tight spot, but they're always good questions, right? Where are these microwaves coming from? Do they come from all sides? We're gonna have to take it apart to find out, right? I don't think I've mentioned it yet in this video, but everything we're doing here is not something you should do at home. Don't put weird things in the microwave, like CDs or wet paper. And don't take apart the microwave either. That's even more dangerous. The microwave has a capacitor inside. It's a kind of battery that can store a lot of energy and release it all at once. And that all at once could happen to us, right? That's why taking apart microwaves or any electronic device usually carries this risk. And some we already know, like tube TVs and microwaves, which have a very strong capacitor. So it's good to be prepared. And I already know how to short the capacitor. In other words, make its energy discharge all at once. This right here is the secret to the whole thing. This is the inside of the microwave. And here, I was almost putting my hand on the capacitor. Let's try to short it first, which is basically this right here. Touch one terminal to the other, and the energy is already discharged. I didn't see anything happen, but that should have been enough. Anyway, I've already disconnected all its connections here. The first thing I'm noticing is that opening and closing the door activates 3 switches here. That's what makes the light turn on and the microwave turn off. It doesn't generate microwaves anymore when the door is open. And I think there must be some kind of timer too, which gets canceled, right? When you open the door, it electronically stops the timer for the food. Check this out. There's a small red button here. Closing the door presses it, and opening the door releases it. Further down, there's a lever that does this with 2 other switches. So when I close or open it, it activates 2 switches at the same time. So let's take this whole part out, right? Here's the panel. Let's check out these buttons, right? Here, the buttons aren't on the board. They're on the outside. I'll need the utility knife for this. There's a flat cable that carries the button information to the board. Ah, there we go. Look. Here we can see all the traces where the energy flows. And each of these little dots is where the contact happens. So basically, it's going to be a set of wires on one side and a set of wires on the other, probably something made of copper. And when you press it, one thing touches the other and lets the energy flow. And the guess is that they use this type of button because it lasts much longer. If you used a touch screen, it would be much more expensive. A touch screen just like the ones on cell phones. And if you use a button like those old ones on televisions, the ones that go clack, the mechanical button, it breaks. So maybe this type of button, by the looks of it, is pretty robust. It looks like it lasts a long time. I'm trying not to damage some parts that we might use later, right? Look here at the microwave light bulb. It looks like an incandescent bulb, 120 volts, 20 watts. Look at the small switch I showed earlier. This here is a fan. It's a little fan that sits in the back. When you turn it on, it makes quite a bit of noise, actually, to cool the whole system. Maybe we can build a soldering fume extractor here on Manual do Mundo later since we need one. We've reached the core of the little guy. This here is the Magnetron. It's what generates the microwaves. It's an extremely sophisticated machine. Before we look closer, should we finish taking it apart? Because then we can better understand the flow of energy here. The The microwave was invented during World War II. There was an American engineer who was developing a radar to detect airplanes, and then he noticed, while he was testing it, that the chocolate in his pocket had melted. So he decided to try it with other things. He put popcorn kernels in, and the popcorn popped. He put an egg in, and the egg exploded. And that's how the microwave oven was invented, which actually started being sold in 1947, a little after the end of the war. Now we have the three main parts of the microwave here: the capacitor and the transformer, and then the magnetron. This here is that part, the capacitor, which I told you stores a lot of energy and can give you quite a shock. This is a transformer. It takes the energy that's at 110 or 220 volts and raises it up to about 2000 volts more or less. These two parts will prepare the power and send it to the magnetron. Inside here, there's a filament that heats up and releases electrons. And then we have some magnets. And there's a special chamber here that makes these electrons start to spin, to dance in a special way inside. And that's what makes the microwaves come out here from the tip. All the power, the energy of the microwave, comes out of this little hole here. So, answering Jansen's question, this part is attached here. So the microwaves go into a very specific place. They don't come out from the whole oven. If we look inside, it's right here. Look. Pay attention. This part is a bit dangerous to take apart because it has a beryllium oxide ceramic, which is very toxic. So I'm just going to open the back to see if we can find this filament that heats up. Music. I'm not sure if I actually reached that filament, but I see two ceramic pieces here, a white one on this side and a pink one on the other. I'm not sure which one. Or if both are made of beryllium, and it's better not to go past this point, Eld. But if it were letra J, he would grab that beryllium thing, put it in Farofa, and eat it. I'm also a fan of letra J, but I want to live to see my daughter's graduate in good health. But wait, don't leave, because my favorite part of the microwave, I still haven't found it. It's hidden down here, and I don't really know how I'm going to take it out. Here under the sun, you can see the microwave shell. It's all metal, okay? Basically, we have a capsule here, which is where the microwaves circulate. And we have a base, which I don't know how to open. I think it also opens by force. We'll have to figure something out, right? Music. Now I saw a screw here. Maybe we didn't need to force it that much. I don't want to damage this part. Let's try the screw again. Today I woke up wanting to exercise, so I'm not using the power screwdriver. This right here. This beauty is the microwave turntable motor. It's a very different motor from what we're used to. Look, it's for 110 volts, but it's a geared motor, and it spins at 4 rotations per minute. So in 1 minute, it makes just 4 turns. Music. I'm going to isolate you here so you don't get shocked. 1, 2, 3, and wow. This right here is practically a jet engine. I'll tape this here so you can see the motor spinning. Look at that. You can even hear it up close. I'll put the mic so you can listen. Music. Like I told you, it's an extremely slow motor. Inside, there must be several gears to make it this slow, kind of like the first gear of a car. And here, with the tape, you can see its rotation. Look what I found out. If I turn on the motor, it spins in one direction. If I unplug it and plug it back in the same position, it reverses. Music. So, curiosity definitely satisfied. If you wanted to know what's inside a microwave, it's a pretty simple machine, but it's genius. We've already filmed a lot of stuff with the microwave, and one that really surprised me was that if you reheat a boiled egg in the microwave, it can explode. Click on this here. It's really cool.